I think what we'll see of this evolution is that the personalization will still be within a framework that is basically mandated by any regulations from governments in terms of what information is required, but also then looks and feels and designs that the car manufacturer would probably put some level of restriction on. So it's not like it's going to be a blank slate that anybody can just draw their own designs, but there'd be like a palette that you would select from, and you could organize the data that way. But again, ultimately, or there may be a variety of different configurations you can select from as a preference. But you can envision, here in Italy, there's a Fiat, and it might have a long history of models. And you could select, do you want the 1965 look and feel? Do you want the 70s look and feel? Do you want the 80s look and feel? So again, there are specific dashes, but it's basically retro. Or you could go to a futuristic look. So there will be customization, but within certain parameters. Well, it's already happening today. Our GPUs are very powerful media processors. So our Tegra processor, again, it's no bigger than your thumbnail. It's able to deliver 2 full HD streams of video. So you could easily have 2 screens in the back of your car that are playing different HD movies. And gaming is another opportunity here. Again, Nvidia comes from a long history of computer gaming, and our processors are great for mobile phones and tablets for playing games. So there's no reason why car makers can't integrate those kinds of capabilities right into the car so that the passengers in the rear seats can be playing those games. Moving forward, I think we see just a huge amount of app development, and it's really, I think, critical that apps have their right place in the vehicle. Rear seat, no problem, but for the front seat, for the driver, those apps need to be essentially restricted so that they're vital to driving and that they're not taking attention away from the driver, but instead there's an interface modification so that the apps can present information that's useful to them, but that they can maybe access it just through voice. So today you have it's called the head unit or the center stack, the middle part of the car where the navigation systems tend to be. And those are kept separate from kind of the drivetrain, braking, or all the other microcontrollers in the car. In fact, many cars today have over 100 processors inside and up to 2 miles of wire. What we're trying to do is reduce that weight, that space, and all that wiring by centralizing a lot of functions on our processors. But you're right, there has to be critical security around those vital functions. And so there's one of the reasons why the consumer electronics product life cycle churns so fast and the automotive industry takes quite a bit longer is because of those kinds of security issues, those testing, that process to make sure that everything is certified. We have to basically have a special GPU made for automotive that's automotive grade that goes through a lot more testing than any of our consumer electronics. And that's because you're in a car and that car cannot fail, right? The systems in that car cannot fail. So to get to your question though about the security side, I think it will be some time before those things start to intersect. From an app perspective though, it's not going to be any developer can create an app and it will go in the car. I believe the car manufacturers will essentially have their own app stores. And so if you have an Audi, you'll get an Audi app or compatible app that's already been tested, validated, certified by Audi to go into your car. And so it's not like anyone will be able to write something that would take over the system of the car. So we take, obviously, manufacturing of all of our products very seriously. But automotive has specific requirements. It's a moving vehicle. You're going over rough terrain. So it's a ruggedized version. There's much greater temperature extremes that the parts are tested for. So there's a different manufacturing process than that they go through to be packaged differently for those different conditions. We don't generally do all that level of testing on our products that go into a PC and sit in a static environment. So it's just much greater testing, and essentially every product goes through much more substantial QA at the end of the day to make sure that there's zero defects. Our strategy within automotive is to really reduce the gap between new releases of consumer electronics and products that make it into the vehicle. So what we've done is we've created a VCM, or visual computing module, which takes our Tegra processor, puts it on a module that can easily be upgraded over time. Now, we don't envision the end customer, the driver, doing their own upgrade, but as a new model year vehicle comes out, and if we have a new processor release, that will enable that car manufacturer to upgrade to the newer technology much more easily. Full compatibility across that line of VCMs, but then they can get the new performance and new features of our latest processor much faster.